Carl the carpenter is a stick figure, and he's hoisting a 14-foot beam up the side of a building. He's pulling the rope at a constant rate of 0.5 feet per second. At what rate is the beam sliding across the ground as the upper end of the beam is 4 feet from the ground? What? Okay, I hope you noticed the triangle here. And they never said anything about angles, and so we are going to just jump right in with the Pythagorean theorem. We've done a similar problem. So we'll call this A, we'll call this C, we'll call this B. We're also going to have dB over dt. We're going to have dC over dt. And we're going to have dA over dt. And we'll figure it out from there. So let's read again. Carl the carpenter is hoisting a 14-foot beam up the side of a building. He's pulling the rope at a constant rate. It's going up of 0.5 feet per second. So this distance is increasing at 0.5 feet per second. At what rate is the beam sliding across the ground? So as he pulls up, the beam goes this way. And they're asking at what rate the beam is sliding. We don't know. As the upper end of the beam, this one, is 4 feet from the ground. Okay? We're missing two things. Well, three if you count the thing that they're asking us about. So if we came over here and we wrote a squared plus b squared equals c squared, and we took the derivative, we'd have 2a dA dt plus 2b dB dt equals 2c dC dt. And in a previous problem, we said 2 divided by 2. And then we start plugging things in. But again, we're missing some stuff. We don't know this, and we don't know this. Let's find them both. Let's actually start with b. Let's find b. It's going to be pretty straightforward. So a squared plus b squared equals c squared. 4 squared plus b squared equals 14 squared. B squared is equal to, let's see, that's 196, that is 16, that makes this 180. The square root of 180 is a thing I don't know off the top of my head. We'll raise 180 to the 1/2, and we get 13.416, and that's fantastic. I'm going to store it as B. So presto, it is B. That way we keep and preserve all of our decimals. So now we know what B is. Lucky us. 13.416. Well, I wonder at what rate the length of the beam is changing. Let's think about this logically. They didn't tell us that, but sometimes things are implied because they're just common sense if we think about it hard enough or easy enough. This is a 14-foot beam. Is the beam changing in length? No, not at all. So let's come back over here and finish our work. 4 times 0.5, that's 2, plus b, which is 13.416, times the thing we don't know, equals 14 times 0. That works out pretty well for us. And so then we will find dB dt. dB dt is equal to, okay, well this is 2, and it would get subtracted over. So 1/2 times 4, of course, is 2, but it gets subtracted, so it's -2. And then we would divide by this, which is b. And so we are going to have negative 0.149. Okay, 0.149 what? We're dealing with the rate at which this is sliding across the ground, and that is feet per second. And we're going to really keep it negative because I said at what rate, and that's the rate. That is truly the rate, negative and everything.